Alright friends, now let's begin testing. We'll check all the switches one by one. In this system, we've used a total of 9 switches, where each switch represents a specific digit in the password. Now, let's say someone tries to enter the wrong password. The system will immediately detect it, and the door will not open. This is a key security feature to prevent any unauthorized access. But the moment you enter the correct password, the system recognizes it. As you can see, the door automatically unlocks. There's also a reset switch located at the bottom. So today we've built a password-protected door lock system. So friends, to build this project, we've used some essential and simple components. First, we took a blank PCB board and installed 9 tactile switches on it. You can fully customize this setup based on your needs. For example, adding more switches, changing the layout, or even using a different size PCB. After installing all the switches, we carefully soldered each pin. It's very important to do the soldering neatly and precisely so there are no loose connections or short circuits. Once the soldering is complete, the board looks clean and professional. Now comes the password part from the 9 switches. We selected any 4 switches to act as the password. These 4 switches will need to be pressed in the correct combination to unlock the system. The remaining 5 switches are used as reset switches, which help clear the input if a wrong password is entered. But you still need to make sure the soldering is done carefully for everything to function properly. This setup works as a basic smart password lock system. Now let's begin by placing 4 capacitors with values 10 volts, 470 microfarads each. These capacitors are connected in series across the switch section of our password mechanism. Their purpose is to help stabilize voltage spikes and reduce noise in the circuit. Friends, the system I've built here is a basic yet highly functional electronic password lock, made entirely at home using simple and easily available components. Huge customization potential, and the best part, this project is just a basic version. You can easily upgrade it further with your own ideas and creativity. Add a fingerprint module for extra security. This adds biometric security to your system. MOSFET connection. Next, we install a MOSFET N-channel. Source pin of the MOSFET is connected to the negative terminal of the 4th capacitor. Gate pin goes to the positive terminal of the same capacitor. This configuration allows the MOSFET to control the current based on the capacitor's charge, acting like a smart electronic switch. Relay installation. After setting up the MOSFET, we now place a 5 volts relay module in the circuit. The relay helps to isolate and control higher voltage devices safely. To prevent reverse current or voltage spikes when the relay switches, we connect a 1N4007 diode across the relay coil terminals. Next, we carefully connect a 470 ohms resistor between the VCC positive supply and the anode positive leg of the LED indicator setup. We now connect an LED as a visual output indicator. This will allow the LED to light up only when the correct password is entered and the MOSFET activates. Wire mounting terminal. Now we install a wire mount connector or terminal block to make external connections neat and reliable. This is useful for connecting power supply or any external control lines securely. Soldering the circuits. After verifying all component placements and connections, now finally, connect a 9 volts battery or an external power supply to the circuit to provide the required voltage for testing. So the first thing I did was connect the wires from the battery to the main PCB. I took extra care to make sure the polarity, positive and negative, was correct. This step is crucial to prevent short circuits or damage to components. Circuit testing. Once the wiring was done, I moved on to testing the circuit. As soon as I powered it on and entered any random password, something interesting happened. The red LED turned on immediately. This is a clear indication that the circuit is functioning perfectly, just as intended. That's all for today's video.